As promised in the previous clip, we will speak today about the Schroedinger's cat. So, what is a Schrödinger cat? That is a thought experiment. No one ever did it on a live cat, so don't worry. And if the question of a dead or a live cat bothers you, you can transform it into a question of, is the cat asleep or awake? But the experiment is as follows. We take a box, and put in a cat, a live cat. Now we take a radioactive particle and put it also in the box, and we put in a detector that measures the emission of an alpha particle. Now, this detector is connected to a hammer, and we have a bottle with poison in it. And since the decay of the radioactive particle is a quantum mechanical process, meaning that we have the same probability of it going to the right or to the left, if it hits the detector, the hammer drops, the bottle breaks, and poison is spread in the box, and then the cat is dead. On the other hand, if the decay of the particle sent an alpha particle to the other direction, didn't hit the detector, and the cat is alive. If we take seriously all that we described previously about measurement, so before the measurement, we have here a superposition of a dead and alive cat. We didn't measure. We don't know what is the actual state of the cat. We know only the probabilities, that we'll have a probability half of a dead cat, a probability half of an alive cat. And until we measure, we can't collapse the cat on a state of dead or alive. Now, intuitively, this is extremely strange. We never see in daily life a superposition, not of a dead and alive cat, not even a dead or alive mouse, not even an insect dead or alive. Never observed. So, should we take seriously this superposition of dead and alive cat? Is it meaningful? So if we're looking into the Copenhagen interpretation, The answer is yes. Now you can say again, sorry, I have never in my life seen a dead and alive cat. The answer is actually buried in details that we gave in the previous clip. Look, when we take this cat, if it's alive or dead, it leaves also an imprint in the environment, in what is happening in the box. A cat that is alive breathes, changes the ratio of oxygen to other gases in this box. A dead cat doesn't breathe, doesn't change, therefore it leaves a signature in its environment that we indeed see later, but it's already recorded, and that's the measurement procedure, and therefore a macroscopic cat is either dead or alive. If we would have put the cat in a situation which it has no interaction with any other physical system, therefore leaves no record of its state, then it could have been in a superposition of dead and alive cat. Nevertheless, as we know, if you'll put a cat in a vacuum and it will leave no record, we can be quite sure that it will be dead. Therefore, the description of this experiment is not really realistic. Because we have always signature in the environment. Well, the second interpretation, popular interpretation of quantum mechanics, the many-world interpretation, tells us that basically, no, we don't have a situation where we have a dead or alive cat, but the reason for that has to do with the fact that we are treating the measurement procedure incorrectly in the Copenhagen interpretation. In the many-world interpretation, we describe measurement by taking into account that also the observer is in a quantum state. Therefore, if we have a situation where the cat is alive, we have also part of the wave function describes the observer as seeing an alive cat. If the cat is dead, then the observer is also in the state of seeing a dead cat. Therefore, we have all superpositions of dead and alive cats occurring at the same time, at the same wave function, but for a particular observer, we always see one of the measurements. A happy observer with an alive cat, and sad observer with a dead cat. Therefore, for a particular observer, we have only one situation, either dead or alive. The price that we pay is that for every procedure of measurement, our wave function becomes more and more complicated because it has to record all the possible results of every measurement. Now, on a mathematical level, this is actually a cleaner interpretation because you don't have the procedure of a collapse of the wave function. We have always all states exist. On the other hand, our personal intuition, our personal experience doesn't subscribe to this description. The only way out of it is that we also all the time diverse into more and more and more observers, and I'm not so sure that this is a better situation intuitively than collapsing the wave function. But these are the two main interpretations of quantum mechanics. And at the moment, we don't have a way to distinguish between them experimentally. And for any use of quantum mechanics that we can think about it, they give no different prediction. So which one of them you prefer to believe in is your personal choice. But as I described in the beginning, for actually calculating results of experiments with quantum mechanics, it doesn't make a difference. That's perhaps why we go back to the old saying of Feynman, shut up and calculate, because for any predictions that you do, it doesn't matter. Thank you.